Air consumption. You can now calculate air consumption. You will certainly remember that pressure increases with depth. Consequently, the volume of the air decreases and the density increases. The air molecules have been pushed closer together. At depth, the regulator supplies air at ambient pressure, which is greater than that on the surface. Therefore, every time you inhale underwater, you breathe in more molecules than you would on the surface. Consequently, you consume more air. So, the deeper you dive, the less time the air in your cylinder will last. There are quick, simple ways of working out how much air we consume per minute under the water. Let's imagine that we are diving at 20 meters, 66 feet of salt water, and we note that the pressure reading is 160 bar, 2400 psi. After 10 minutes spent at the same depth, we see that the pressure has fallen to 120 bar, 1800 psi. This means that in 10 minutes at that depth, we used or consumed 40 bar, 600 psi of air, or rather, your air consumption is 4 bar per minute or 60 psi per minute. With this consumption rate, the remaining 120 bar, 2400 psi in the cylinder will last another 30 minutes at that depth. But if we ascend to a shallower depth, where we will consume less, you will be able to stay there longer. It would be handy if we could also calculate our autonomy at this depth too. An easy way to do this is to use a single reference value, your own personal surface air consumption rate. To work this out, just divide your air consumption rate at depth by the absolute pressure of that depth. In the earlier example we looked at, the consumption rate of 4 bar per minute, 60 psi per minute, was calculated at 20 meters, 66 feet of salt water, where we have an absolute pressure of 3 attar. The surface air consumption rate in this case is therefore 1.33 bar per minute, or 20 psi per minute. To calculate the air consumption per minute at a given depth, so we can work out our air autonomy, just multiply the surface air consumption rate by the absolute pressure at that depth. For example, at 10 meters, 33 feet, of salt water, where the absolute pressure is 2 attar, the air consumption would be 1.33 bar per minute, 20 psi per minute, multiplied by 2, giving a result of 2.66 bar per minute, 40 psi per minute. At this depth, the 120 bar, 2400 psi of air would last for 45 minutes. On your next dives, your instructor will have you calculate your surface air consumption rate. However, you should be aware that this is a simplified calculation and does not take into account factors that could increase your air consumption, such as cold, fatigue, or stress. You will have undoubtedly noticed that there is a considerable difference in weight between a full and empty cylinder. The air that was inside has been used. This means that the condition of buoyancy also changes, so at the end of the dive, your total weight will be less. As we said earlier, the difference is considerable. For example, an empty European 15-litre cylinder weighs about 3 kilograms less than one filled to 200 bar, and an empty North American aluminium 80 cubic feet cylinder weighs about 6 pounds less than one filled to 3000 psi.